In this video, we will use tools such as tRPC, Next.js, Prisma, Postgres, JSON web tokens to authorize the user, and once they are authorized, we will show them our pro features, or you can say blocks. You can of course make changes on whatever you want to show them. And here, this is what we are actually going to build in this video. Here, we will first register the user. So here we will provide the full name, which is going to be admin, and the email is going to be admin@admin.com. Then we will have the same password and confirm password. Then we will hit register over here. And you will see that it says that email already exists. So what we are going to do is we are going to say admin2@admin.com, and we will provide the password same as email. So let's put over here and let's register. And there we have this toast message which said registered successfully. Then it takes us to the login page so that we can have access to the pro page. So let's put in the email that we have and the password, and then let's hit login. And there we got another toast message which said login successfully, and the links also changed from home register login to home pro page and layout. So when we go into the pro page, then we will have our blog section over here, which only authenticated user can actually look at. But now you might wonder, what if someone tries to access this URL without authorization? Well, let's do that too. What we are going to do is we will first log out, and then we will have this logout successful, and it took you to the login page. Okay, and now let's try entering this URL. Okay, and hit enter, and you will see that it redirected you to the login page. So that's what tRPC Postgres and JWTs do. So open up the terminal, and here in the terminal run the command node-v and docker-v to check if you have node and docker already installed on your computer. Then in your root directory run the command npm create next-app and give your project a name. In my case, I'm going to give it as tRPC Next.js app. Alright, you can name it anything you want, and then let's hit enter. I'm using pnpm over here, but you can use npm or yarn, whatever would you like to use. And yes, we want to use TypeScript, so hit enter. And then again let's hit enter. We want to use tailwind, and we don't want to use the source directory, so let's hit no. Okay, and now follow along with me. Yes, okay, alright, and now it is installing all of the dependencies that we need. Okay, so let's wait for a moment, and now that it has done creating our project, let's navigate into our project. And next thing we need to do is to install the dependencies. To use tRPC and JWTs, we have dependencies to install. So these are all of the dependencies that we are going to need. And the next thing we need to do is to open Docker desktop on our computer and log into it, because while pulling an image of Postgres on our computer, we need Docker daemon running. Alright, then let's go back to the terminal, and here let's run the command code followed by pred to open this project folder into our VS Code. And now in this project directory, the next step we need to do is to create a docker compose.yaml file. Alright, in this file, we are basically going to define two services, one for Postgres and second one for PgAdmin. Postgres will use the latest Postgres Docker image, and we name the container Postgres. Also, we map port 6500 on the host to the port 5432 in the container. And we mount a volume named PostgresDB for persistent data storage. We also read environment variables from a file named .env. .env file we are going to create in a moment. PgAdmin service uses the PgAdmin for Docker image, and we name the container PgAdmin. And we also read environment variables for PgAdmin from the same .env file. And maps port 5050 on the host to port 80 in the container. Additionally, we have a volume named PostgresDB. It is defined outside the service. Basically, it is going to allow the database data to persist even if the container is stopped or removed. Now that we have our docker compose.yaml file ready, the next step is to connect this application to the Postgres database using Prisma. So to connect our application to the database, what we are going to do is we are going to create a .env file in the root directory of this project, and here we start by Postgres configuration. So basically first we are going to say that our Postgres database is hosted on the local machine and it is running on the port 6500. Then we connect the username Postgres to it, and the password for our Postgres database is going to be password. And then the database we are going to use is going to be named tRPC underscore Prisma. You can name it anything you want, alright? Then we also have a database URL. This URL is specifically for Prisma, providing all the details needed to connect to our Postgres database. Now we are done with Postgres configuration. The next thing we want to configure is PgAdmin. So we are going to set a default email to access the PgAdmin, which is going to be main@main.com. And we also want a password for PgAdmin, and it is going to be password. And now that we have our .env file ready, the next thing we want to confirm is that this .env file is present in .gitignore file. And if it is not there, what we will do is we will write it over here, .env, just like this, because we don't want this .env file to get published on our public repository, alright? Now that we have docker compose and .env file ready, the next step is to open up the terminal, and over here what you're going to do is you're going to run a command docker compose up-d. It is going to pull Postgres and PgAdmin image, and now here you will look that these both containers are starting. It might take you a few moments, but let's wait, alright? Now let's check if both the containers are running. So for it we have a command docker ps-a to check if the containers are proper and running, and here we have got the name and image of the containers. Alright, so both of the containers are running. Okay. Now the next thing we want to do is to perform database migration with Prisma. Migrations are necessary because it might happen that we want to make changes to our data model. It might happen that you are going to add tables, modify the columns, or you can do something with your database. So we have to perform a migration. So for it we have a command pnpm prisma init --data source --provider PostgreSQL. Basically, this is saying that our database is Postgres, and then let's hit enter. This is going to create prisma.schema file in our project directory, and there we have this Prisma folder inside which we have schema.prisma file. In this file, we are going to define how our database will store user related information, and it is also going to include an enum for user roles. It is going to be either user or admin. So basically in this file, it is saying that our database source is connected to Postgres database. This database connection URL is pulled from our environment variable which we created earlier. Now we start off by defining our user model. The user ID is automatically generated and set as a primary key, and we have a username with a character limit of 255. The user email is going to definitely unique across all user. We also have a boolean flag indicating if user is verified, defaulting to false. Then we also have user's password. The user's role either is going to be user or admin, which is defaulting to user. And then we have password for user. The user role is going to be either user or admin, which is set to default to user. Then we have two timestamp, which is for one when the user was created, and the next one is for when the user was last updated. And the provider of the user is set to local by default. And we also map this model to a table named user. And we wrap it with an enum for the user role. Prisma is going to use this schema to generate a file that can be used to interact with the database in a safe manner. After we are done with this, let's save this file, and after this open the terminal and run the command pnpm prisma migrate dev -- name init to generate our migration file. Here we are instructing Prisma to perform a database migration in the development environment. This is used for applying changes to the database schema, such as creating or modifying tables or to reflect the changes in our Prisma schema file. And now if you look over here, it says that we need to reset the public schema at localhost 6500. Basically, I also have a prisma.schema file for another project, and that is why maybe it is giving this error. So I'm just going to continue and I'm just going to select yes. And then it has created our migration file, and now our database is in sync with our schema. Now let's use PgAdmin app if you have it in your local machine, or you can also use it on the browser on URL localhost 5050/login. And here let's put the email that we put in our .env file, and then password, which was basically password, and then let's hit login. And now the next thing we need to do is we need to register a server. So click on this server, then go into this object, click on register and then server. Here let's type the name Postgres, and in connection let's type Postgres, and for the username let's put Postgres, and maintenance database it's going to be tRPC Prisma. Alright, and then provide the password, which is basically password, and then let's hit save. Okay, and there we have this Postgres over here. When you open this database, inside this you will find this two, Postgres and tRPC Prisma. Open this tRPC Prisma. Inside the schema section, we will have two tables. Here we have this table, and inside this we have two tables, one for Prisma migration and second one is user. Prisma migration is used to track schema changes, and then user, which is going to represent user model we define in prisma.schema file. Now let's head back to our code editor, and in this the next thing we are going to do is we are going to create a lib folder. Inside this lib folder, we are going to create prisma.ts file. This file is going to be used to set up a singleton pattern for the Prisma client. It's a tool for database access, alright? And here we start by importing Prisma client from the Prisma client package. Then we declare a Prisma client singleton function that is going to return a new instance of the Prisma client each time it is called. We also declare a global variable named Prisma in the global namespace and set its type to the return type of Prisma client singleton or undefined. We then initialize the Prisma variable by assigning the existing global Prisma variable or creating a new instance using Prisma client singleton. And when we are in a non-production environment, we are going to update the global Prisma variable to the newly created instance. This is going to ensure that the changes to the Prisma client during development take effect immediately. Then we also export this Prisma instance, making it available for the use in other parts of the application. Now let's save this file. Now we are going to use Zod to validate the user schema. This is going to help us enforce a consistent and validate structure for the user input while user creation and login processes. Zod is going to provide clear rules and error messages for everything. So in the lib folder, let's create another file that is going to be user-schema.ts. In this file, we start by importing object string and type of function and types from Zod library. Then we define a schema create user schema. Inside the create user schema, we define a schema for creating a user with field such as name, which is a non-empty string, and email, which is also a string, and it should be a valid email address. Then we also have a password, which is also a non-empty string between 8 to 32 characters. Also, we have password confirm, which is also a non-empty string to confirm the password. These are all the validation rules and custom error messages for create user schema. We are also going to use .refine to ensure that the password and password confirmation matches. And then we have the login user schema, which is an object and it has email and password as a field that are required for a user to log in. We also have two input types, create user input and login user input. Create user input is going to represent the expected input type for creating a user based on the create user schema. And similarly, login user input is going to represent the expected input type for user login, and it is also based on login user schema. Now we are done creating schema for our user model. And the next thing we need to do is open a .env file and add an environment variable for JWTs. Because now we are going to create a tRPC authorization middleware, which is going to ensure that only users with valid JWTs can access remote procedure call, or we can say RPC. So in the directory, let's create a folder named server, and inside this server, let's start with creating an auth middleware file. In this file, we start by importing tRPC error. It is an error class used for handling errors. We also import JWT, Prisma and cookies. We also declare a function named deserialize_user that is going to be responsible for decoding and verifying a JSON web token stored in a cookie, and then fetching user information from a Prisma database. We first attempt to retrieve the JWT token from a cookie named token, and if there is no token, we are going to return an object with a null user to indicate that the user is not authenticated. Then we declare variable secret and decode it to decode and verify the token using a secret from the environment. We first attempt to retrieve the JSON web token from a cookie named token, and if there is no token, we are going to return an object with a null user to indicate that the user is not authenticated. Then we declare variables secret and decode it to decode and verify the token using a secret from the environment. And we also fetch the user information from the Prisma database based on the decoded user ID. And if the user is not found, or if there were any issues during the process, we are going to return an object with null user to indicate unauthenticated status. We then also remove the password field from the fetched user object, and we are going to return an object with authenticated user information. And if the user is not found, or if there are any issues during the process, we are going to return an object with a null user to indicate unauthenticated status. We then also remove the password field from the fetched user object and return an object with the authenticated information. And in the catch statement, we catch any errors that occur during the process and throw an tRPC error with the specific error code and message, indicating an internal server error. Now that we are done with this auth middleware too, let's save this file. And one thing I noticed that we did not save .env file, so let's save that too. Now we are going to create a tRPC procedure handler function so that it can handle user registration, login and logout in our application. So in the server folder, let's create another file which is going to be auth-controller.ts. In this file, first off, we have got some imports bringing in the tools we need. Create user input and login user input are just types for the data we will get. Bcrypt will help us hash passwords securely. Prisma is going to connect us to the database. tRPC error is used for handling errors, and JWT is for creating and managing tokens. Lastly, we use cookies from Next.js to handle HTTP cookie. Now let's declare a register handler function for user registration. Inside the try statement, we are hashing the user's password here by using bcrypt. Then we create a user in our database using Prisma. It has data such as email, name, password. Okay. Also, we remove the password from the user object before responding. Finally, we will send a success response back with the user's data. Inside the catch statement, we will see if there is an issue. We catch errors here. If it's a duplicate email, we throw a custom conflict error, and its messages email already exist, alright? Otherwise, we rethrow the error. Now let's let's move on to the login handler for handling user login. Inside the try statement, we say we look up for the user in the database based on the provided email. And if user doesn't exist or the password doesn't match, we throw a custom error. And the message it is going to show is invalid email or password. Now we generate a JSON web token with the user's ID and sign it with a secret. And also we set the token as an HTTP cookie with some options, which is HTTP only set to true, path is /. Lastly, we also send a success response back with the token. If there are any errors, we are going to throw them over here, alright? And finally, we have a logout handler for handling user logouts. We clear the token cookies by setting its max age to -1, and we send a success response in the try statement. And if there's any issue, we catch the errors here and rethrow them. And now we are also done with creating a tRPC procedure handler function for user registration, login and logout. So let's save this file also. Next, we are going to create a get user handler which will be responsible for fetching and returning the details of the currently authenticated user. It is going to rely on custom context which will hold user information and throw an tRPC error in case of any unexpected error. And it is also going to ensure a more controlled and structured error handling approach. This is going to be a part of our application where we fetch the current user details. So in the server, let's create one more file which is going to be user-controller.ts. First, we import the context type from our custom tRPC context utility. This context we are going to create in a matter of moment. This is going to hold information about the current request like the user's detail. We are also bringing in the tRPC error class for handling errors. Now, we will look at the function itself. We start by grabbing the user information from the context. This is going to be set during the authentication process. And if everything goes well, we send a success response with the user data. And in case there's an error, maybe due to some internal server issue, we catch it. And we throw a custom tRPC error to handle the error gracefully. This is going to include an error code and a message. So save this file, and now that we have created the RPC handler function, the next step is to establish routes that are going to trigger these functions. To start the things off, we will configure the tRPC context to make use of JWT middleware function. So in the project root directory, let's create another folder which is going to be for utilities and name it as utils. And inside this, we are going to create one file that is going to be trpc-context.ts. In this file, we start by importing the deserialize user function from our custom auth middleware. This function is important for converting a user token into a user object. We also import a infer async return type from tRPC, which is going to help us automatically infer the return type of asynchronous function. Now let's check out the create context function. This function is quite straightforward. It just called deserialize user, which is going to return a promise that resolves to the user context. But wait, there's a neat TypeScript trick here. We use infer async return type to automatically determine the return type of create context. This is going to ensure that our context type always reflects the type of what create context resolves to. And if you saw carefully over here, the red error from here went because we created tRPC context. So let's save this file also. Now we are going to set up tRPC procedures and a router for handling user registration, login and logout in a secure and organized way. In the server folder, let's create a file named auth-route.ts. First thing first, we have to import schemas from user schema.ts file that is going to define the expected input for user registration and login and what is going to be the type of input. Now we are going to import some utilities from the tRPC server that will help us manage access control and procedure. This we are going to create in a matter of moment. And of course, we need our trusty handler function that takes care of user registration, login and logout. Now we will create a tRPC router. It's going to be a set of rules for handling various requests. First up, we define a registered user procedure. It is a public procedure, meaning anyone can access it. We are also specifying the input validation schema using create user schema, and we connect it to the register handler function. Next, we define a login user procedure, also public, with its own input schema, and it is connected to the login handler. Lastly, we also have a logout user. This one is protected, meaning only authorized user can trigger it, and it is connected to a logout handler. We then export our auth router, which is ready to handle authentication related requests in our application. So let's now save this file and let's grab this name trpc-server, and in the utils folder let's create a file named trpc-server.ts, not js, sorry, .ts. In this file, we start by importing some essentials from tRPC server and super.json, and also here we have got a custom context defined in tRPC context. Let's import that too, alright? Now we are going to initialize tRPC with a specific context using init tRPC, and there we have a middleware called isAuth that checks if the user is authenticated. If there is no user in the context, we throw an unauthorized error, but if the user is authenticated, we continue to the next middleware or procedure. Next, we are going to define two procedures, public procedure and protected procedure. Public procedure, as the name suggests, is open for everyone, while protected procedure is going to require authentication. Now we are going to set up tRPC routers and create a unified app router. So to set up tRPC router and create a unified app router, navigate to this app directory. Inside it, let's create one folder named API. Inside this API directory, we are going to create another folder which is going to be tRPC, and inside this tRPC, we are going to create one file named tRPC-router.ts. In this file, we start off by importing our authentication router from auth-route. We also bring in the get user handler from user-controller file for handling user-related queries. Additionally, we are also going to import the create context function from tRPC context. This is going to be used for creating tRPC context. We are using the protected procedure and tUtilities from the tRPC server. Now, we are going to define a router which is specifically for status checking. We have another router for user-related queries, specifically get user. Now, let's merge our routers into a unified app router. We are also going to create a caller factory function from the app router. Additionally, a factory function for creating an async caller with the context. Lastly, we define the type of our app router. This is going to set up tRPC router for status checking, authentication, and user-related queries. We have created a unified app router by merging these routers, and we have also provided functions for creating callers with and without an asynchronous context. Now we are going to create tRPC HTTP route. So in this tRPC folder, create a dynamic folder which is going to be tRPC with the square bracket, and let's hit enter. Inside this, we are going to create one file which is going to be route.ts. In this file, we are going to set up a request handler using tRPC and fetch. We will start by importing the fetch request handler from tRPC servers, adapter, and fetch. We are also going to bring in our app router from the tRPC router and create context from the tRPC-context. Now let's define our handler function, which is responsible for processing incoming request. We also log the incoming request URL for the bit of visibility. Also, we use fetch request handler to handle the request with tRPC. Endpoint is where the tRPC routes are exposed, and we also have the incoming request objects, also main tRPC router, and we also have a function to create a tRPC context. At at last we are going to export this handler function for both get and post requests. Now that we are done creating routers, so let's save this file and open up the terminal, and in this let's start our server by running the command pnpm dev. So our application has started on localhost 3000, and now that we are on localhost, we are going to try to get access to the get user RPC, which was a private procedure. So here let's hit enter, and you will see that it gives the message that you must be logged in to access this resource because it was unauthorized and we need authentication to access this get user. But what if instead of get user we say status checker, and let's hit enter, and you will notice that it gives the message of success which say that welcome to tRPC server. Because this status checker RPC can be accessed by anyone even if they are unauthenticated. Alright, so get user was a private procedure and status checker is a public procedure and can be accessed by anyone even if they are unauthenticated. Amazing, isn't it? And that is all with the authentication logic. And that wraps this video over here.